Okay, so we have a new file, so we'll create a new file. Now, as we started, the last example which I took was on histogram, and it was a very quick example which I wanted to just to show you because we had some time in hand. So let me begin with histogram again. Okay, so the function which we saw last time, if you want to create a histogram in R programming, we make use of the function called hist. Okay, and the parameter which it takes is a vector, or it can also take a matrix as a parameter. Okay, vector is nothing but the values for which the histogram is to be plotted. Okay, so we are going to make use of inbuilt data set right now. Now, instead of creating some vectors and then using it, I thought let us take an example from the data set itself. So the data set which I'll be using right now is air quality data set. Okay, it's an inbuilt one. It gives you the data of daily air quality measurement in the New York City. Okay, so I was just exploring that from where this data has come. So this data belongs, it is about the air quality in New York City, and it is from May to September 1983, 73, sorry. So it is an old data set. Okay, and it is always packaged with our programming language. Okay, now just to see this data set, what we'll do is we'll display the structure of this data set. So let me give str for the data structure, the structure of the data set. Okay, and I'll give air quality. Okay, air quality. Now this is you can see this, it gives you daily air quality measurements in New York. Okay, from May to September 1973. So it's a bit good data set which we can use, and we can draw some visualizations from this. Let us run this one. Okay, now once we run this, you can see we have 153 observations. Okay, there are 6 variables. So we have the first column, you can see the first column, ozone, then solar R dot R, then we have wind, temperature, month, and the day. Okay, all these are integer values. We also have a num value where we have some decimal point, decimal numbers or floating numbers, you can say. Okay, now one more thing you might observe here is that we also have NA value. You can see this NA. Right? So totally 153 records are there. Okay, so we'll have sufficient number of data. So instead of creating a vector and then using it, I thought if I get lots of data and some random data, because usually when we put some dummy data while creating a vector, we might not get the exact image or the chart which gives you the right picture. Okay, now in this we have this column called temperature. Okay, so let us use that. So what I'll do is I'll create another say a field, a variable, say called temperature. Okay, and to this I'm going to assign the air quality dollar and the name of the field. So this values will get stored here. Okay, so here you can see now it's created a variable called temperature int 1 to 153. Okay, 67, all these values have come here. Clear? Now to create a histogram, last time we saw it's a very simple function, hist into bracket. I can just pass my values. So here I can just give temperature here. Okay, and if I run this, okay, I get a histogram, and here it is my basic histogram, we can say. Okay, so we can see here in the plot area, there are around 9 cells with equally, which are equally paced, properly done with proper breaks in between. Okay, it's and in this case you can see that the height of the cell is nothing but equal to the number of observation which is falling in the cell. Okay, so that's why you have this frequency here. Okay, so the number of observation which is having, let us say if this value is say around, I think this is 5, so might be this is and this, so might be around 8 or something, 8 or 10 something. Okay, 8, 9, 10, somewhere there. Okay, so temperature between, say, if this is 10, might be this is 55 or something. Yeah, so there are around 8 or 9 observations, you can say. And it gives you the frequency. Always remember your histogram can give you frequency. But if you want, you can also plot probability. Okay, we'll see that how to do that. Okay, and there are more parameters as well, which we saw in the other charts as well, like your mean is one parameter which is used frequently to give the title for the chart. Now, this is the default title which has come, histogram of temperature. That's the default one. If you want to change it, we can use mean. Okay, then we have this for X labels, and for Y label, we have X lab, LAB, and Y lab. Okay, to provide the labels for the axis is that is your X axis and Y axis. We also have, if suppose we want to fix this range which is down here in the on the X axis and the Y axis, we can fix it by giving the limit by X lim, that is X limit, X lim, that is how we give, that is the parameter. So let us do one thing. We can also, if suppose I don't want frequency, I want probability, then there's another parameter which is known as frequency equal to false. Okay, not the full word frequency is used, FREQ is used. If I set that to false, what happens is I'm able to create you can say histogram of probability and not of frequency. Okay, so let us do one thing. We'll we'll make this some changes here in the same chart and give some more parameters. So let me give a comma here. Okay, let me give main. So I'll give a different title. Let me put it in the next line. So I'll give main equal to, okay, we'll give some title for this particular chart. So let us say maximum daily temperature, that's all. So I'll give maximum daily temperature at New York City. Okay, this is fine. I give a comma. That's the title for the chart which I have given. Now on the x-axis, the label which I want is, let us say, temperature in Fahrenheit. We'll put temperature in Fahrenheit or something like that. So we'll give X lab. That's my label for the x-axis. So temperature in Fahrenheit. I'll just give FAHRENHEIT, Fahrenheit. Okay, give a comma. That completes my X label. Now I can give, I'm not giving anything on the y-axis, no label there. I will keep it as it is. Let us give the limit now, because if you see the default limit here, it might have started with some 50 or something. We'll specify the limit. So XLIM, I can give this one. And because there are two values, I need to give in C. So I give 50, say 100. Okay, you can decide depending on how the histogram you would like it to be displayed. So, and you can give the limit as well. Let's give a comma. Now I want to give some color to this particular histogram. So let us give, say, call equal to, we'll give a very basic color, and the famous one, the blue color. There are multiple colors on different types of, you'll find that it is available. Now, if I run this one, okay, let me run this, press Control Enter. Okay, here you can see now this is, you can see this, the scale has changed. Okay, now the X label has changed, temperature in Fahrenheit from 50 to 100, that is the limit which I have mentioned. Okay, and the frequency, this is your y-axis. We have not done anything on the y-axis as yet. Okay, the color of the bar has changed. Okay, and this is my title which I have given. Okay, now if I suppose I don't want frequency, I want probability. Now what I'll do is I'll give a comma. Let us give frequency equal to frequency, that is FREQ in short, equal to false. Okay, and if I run this, okay, you can see this now, it's changed to density. Right? So this is in a way you can say probability, probability chart. Fine. Now, note that, your y-axis, only the label has changed instead of frequency, and nothing else. The other things remains the same. And the total area of this particular histogram, as you know, the probability, the total is always 1. So the total area of this histogram is also equal to 1. Fine. So this whole total area. Reason, the total of all the probabilities should always be equal to 1. Fine. Now, there's one more thing which we would like to see, especially in this case, when I suppose I want to know what this function hist returns. Okay, so the return value of hist can also be captured, and I'll get all the different types of parameters based on which the histogram is created. Okay, so let us check that, because on line number 5, what I'll do is I'll write h equal to hist, and I'll run this one once again, so that I get the values. So here you can see one, you can say, list of 6 variables has been created. So I'm getting a list, and we have this h. Let us display what is there in h. Okay, so I'll just give h here and just run this. Okay, and you can just go through this one. Okay, there's very interesting things here. Now, if you look at the first list which we have, so there is totally 6 lists which has come. The first one is breaks. Okay, now breaks indicates the places where you want to give a break in the the bar, you can say, which is coming. So if you look at the first value 55, okay, so this first value is 55. Okay, next is 60. So here we get the break here, 60. Then we have 65, then 70 and 75 and so on. And this is the value. Okay, so based on this value, the breaks are given in the histogram. The second list is about counts. So counts are nothing but the number of observations which is falling under that particular cell. So if like in this case, we have, if suppose we have 8 values, like here you can see this 8 here. Okay, so this whole number of values which is falling under this observation, okay, from 55 to 60, this one, the first bar, okay, then counts is 8. Okay, and the last one is 2. So this one is 2. You can see this one here, 2. Okay, so this list gives you the total number of observations which is falling for that particular cell. Okay, the cell can be like from the range 55 to 60 would be 8, from 60 to 65 would be 10, and so on. Okay, the next one is the density, and density is nothing but the density of the cell. Okay, that is the mids. You can say another one is the mids of the you can say the cell, the midpoints, you can say. So if you look at this one, the first one, if you look at from 55 to 60, the midpoint is coming 57.5. Okay, similarly we have from 60 to 65, we have 62.5, and so on. Okay, now why we are going to and how to use this, we'll see in the next example. All these values will be used. Then we have this x name, that is the temperature which we are giving. Okay, so x name is nothing but the x argument name. Okay, the argument which is on the x axis. Fine. And the last one, which you have the equidistance. Logically speaking, it is it takes logical values, and if it is set to true, equal space is given between the breaks. So if you look at this histogram, the bar which are coming off is of the same width, you can say. Okay, and that's the reason your breaks also having an interval of 5. Clear? And if you look at the last one, that is the class, it is mentioning histogram. Okay, so histogram is the class which it returns. Okay, so this is a brief about what this function returns. And if I want to make use of this, and based on this values, your histogram is created. Okay, now there's one more function which I would like to use, is the text function. Okay, so we'll use the histogram return values for the labels using the text function. So let me just go and give a text here. I won't display this value. So I have one like on line number 5, I have the function here. Fine. Let me give the limit. So I'll give the y limit as well. So I come here, I give YLIM limit equal to, and I'll give again, see, now I want this to be between 0 and let us give 40 was the value. So I'll give 0 comma 40, comma 40. Okay, and I don't want this to be false, so I'll just remove this one. I want the frequency to be displayed and not the, you can say, the density. Okay, the problem, I don't want the probability charge. Fine, so if I run this one, let us, I hope this is done. Okay, what happened? Something.
Column, so comma, so y limit.
Y limit. Okay, this one missing. Thanks. Okay. So here we get the frequency, and I have set the limit. Now you can see it's 0 to 40, and we have the limit here also. Fine. Now I want to make use of this list which I saw in this collection of the 6 list in H. Okay, which is returned and from by this hist function and stored in H. So from this, I'll be using a text function to get some value. Now I'll do one thing. I'll just keep this main. Well, let us change this. So I'll give text. So t text. This is the function. Okay, the first parameter. Let me give. I want the midpoints. I want to display the labels. So I'll give. It was H and dollar mids. Okay, that's my first parameter. And I want the second as the counts I want to display here. So I should get 8 on this top here. Okay, and I can give H dollar counts. Fine. The labels which I want to appear on each bar, you can say on each bar, that will be like labels equal to H counts, the one which I have used there, counts. Okay, and there's one interesting parameter in this text function that is known as adjustment, EDJ. Okay, which you can see is between 0 and 1. Okay, the value is between 0 and 1, and you can see that they have mentioned here. Okay, so if you want the labels, so with 0, for left and bottom, 1 is for right and top, and 0.5 is for center. Okay, so in this example, we'll give it in the center, and I want on the top of this bar here. So adjustment I can give here because there are 2 values I have to give. I'll give 0.5, and let us give 0.5 again. I want to just check it out. We'll fix this values again. Let us run this one. Okay, now this is not looking good because it's coming on the exactly on this line. So instead of 0.5, if I give a minus sign, that I think it should fix it. Yeah. Now let me do this again so that I get a new chart altogether. And finally this. Yeah. So here we can see using the text function, we were able to use this, the location. So we gave the values, the mids, the counts which I want, and the labels. So as a label, so using these 2 values, I was able to place the label on the bar, each bar. Okay, and this is for the adjustment, whether you want it in center or left or right. Okay, so we already saw that adjustment and the values. So okay, you can just do some changes here and check it out on your own how the label would get displayed on your histogram. Okay, now let us go ahead and look into this the number of breaks. If suppose now here, because it is equally divided. Okay, if suppose I want to specify the breaks on my own, I can do that as well. Now, if I just for an example, if suppose, let us draw another chart. If I write a hist into bracket, I want this temperature, okay, comma, and I want a different breaks, breaks equal to, I can give some value here. Let us give breaks as say 4. Okay, and I'll just give a title to this so that the main, I'll say with say 4 breaks. or we can write breaks equal to 4. That because this 4 breaks doesn't look good. Okay, I'll just give breaks equal to 4. Okay, and let us run this one. Okay, here you can see now with breaks equal to 4, we have this this whole division. Okay, now you can see the bars have become a bit bigger. Now, similarly, if I just change this, look at how this changes happen. Let us give a very big number. Let us give 10 first, and then check it out. I'll increase the values. Now you can see the 10 values are there. Now I think this was the original one. Let me increase this breaks. Let's give 20. Now look at how this chart will change. Here it is. Okay. So what is happening? If you look at the first bar, okay, if you look at this, the first bar, the value is not 8 right now. It is, I think, 5 and one more, I think 6. Okay. And the remaining 2 values have come here. You can see this one. So my, your x axis is getting broken down. Okay, based on 20 values. So if you look at this totally, you'll find that there are around 20 values there. Okay, this was the original one, right? Let us display this one. Okay, and if let me give a break here. I give breaks equal to say 15. Okay, and let me run this one. Okay, here you can see now. So it's changing, it's breaking my point, or the break points like we saw in the previous case when we displayed the value of h. So if I display the value of h, okay, the breaks were different, like it was starting from 55. Okay, now you look at the breaks. The breaks were starting from 56, 58, then 60, then 62, and so on. So depending on this number which we have given breaks, the value has been changed. Now, if I change this further, and I had given 4 before. Let us run this. Okay, here you can see, and I'll run this as well. And we can come here down. Okay, here you can see now the breaks have changed. Okay, 50, then 60, 70, 80, 90, 100. Fine. So depending on this value, if you want, you can always adjust this value and get a different type of a histogram as well. Okay, now can I give multiple values for breaks? I can. Okay, so I can have a histogram with a non-uniform width also. Okay, some width is less, some is bigger, and so on. Now let us do that one. So I'll just remove this. I don't want this to be here. Let us keep this as default when this is better. Okay, now if suppose I want to have a histogram which is having a non-uniform, you can say, or uniform breaks. Some might be say 5, some might be 10, like this. Okay, or we can directly mention the break values. Like I started with 55, so let us start with 55. Then if I want to give say 60, then I have to give say some other value. Let's say directly I want to give 75. I can do that as well. Okay, so what I'll do is I'll make use of this value here. So X limit is already mentioned, Y limit is given, the color. Let us change the color and give some. Now, you'll be surprised. There are colors like if I want to give brown, I can give brown. I can also give chocolate. So CHOCOLATE, chocolate. Okay, so you'll get a chocolate color as well. Okay, so this, and let us give the border. I can give border equal to, let us give this as red. Okay, red border. So I'll just put this down for just more clarity of uniformity. Okay, don't forget comma, enter this again. Now I'll give breaks now. Okay, breaks equal to, now instead of giving a single value like we gave it in previous one, because we have multiple values, I need to pass it as a vector. So I give C into bracket. Now the values, let us give, say, we'll start with 55 only, because the X limit we are starting with 50. So 55, comma, let us keep the next value at 60, comma, let us give a bigger jump, 70, 75. Let us give say 80, and let us give the last one as 100. Okay, something like this. So here I have given, and you can see it is not uniform. Okay, the first break is at, starting from 55, it's at 60, then at 70. So there's a gap here. It is this, a break of 5, you can see units here, whereas here it is 10, then 5, then again some 15, then some 20. Okay, so let me run this one. There's something wrong. Okay, can you tell me what is wrong, guys? Let me run from here. This fine. Did I give it properly? So I gave temperature, then I mentioned the limit. I gave change the color, and the values are not coming. So okay, let me do one thing. Let me give let us give a histogram here. There might be say something which hist temperature, this first parameter. Okay, now I'll give the main title. Let us give main equal to temperature. I'll just give temperature or max temperature, max daily temperature, max daily temperature. Okay, comma. Then let us give X label. The X label, I'll just give temperature. Right now, I'm just moving it quickly so that we can complete this example. X limit, we'll give X limit, and the limit was 50 and 100. So 50, 100. Okay, what else? Give a comma. We won't set the Y limit. Let us leave that. The color I have to give is the chocolate color not available. Let us give something different. If let us give, say, dark magenta. Let us give magenta. Okay, dark magenta. This is fine. And let's give a comma. Color border we have to give. Or we'll skip on border. Let us skip on this. Directly, I'll give breaks equal to C into bracket. Start with 55. Okay, comma. Then we give 60, comma 70, comma 75, comma 80, comma 100. Okay, this, I think it is fine. Let us run this one. Okay, fine. Now, what was the problem before? I don't know. Fine. So yeah, you can see, look at the bars now, the intervals. So this was starting from 55 to 60. You can see this one, the small bar. This was the standard which we were getting. Now here, look at this one. This is 10 from 60 to 70. Okay. And look at the last one from 80 to 100. Fine. So if you want, you can do this as well. And you can see by default, density is getting plotted in this case. Excuse me. Clear? So, your breaks can also be adjusted. If you want, you can do that as well. Clear? Now, if I say, I wanted frequency. So if I give here FRE frequency equal to true. Okay, this is my frequency. No, this is my frequency. Okay, so just okay, by default we were getting before, because might be somewhere we set as frequency equal to false, and that's why density was coming. Clear? I want you all to rejoin the session once the session gets over. Fine. Now there is one small thing which I wanted to show, especially regarding the bar plot. Okay, the bar plot which we did last time. Okay, so for the bar plot, I just want to show, if I want to display a bar plot which is horizontal. Okay, we can do that as well. Now let me take one example of, again, the temperatures only. We have this temperatures here. So if I want to plot this 1. So let us take, say, max dot, say, temperature. Okay, so I think I do have this. Let me display this, max dot temp. Okay, so I have some values there, max dot temp, so maximum temperature. Okay, using this, I'll just plot a bar plot. Let's give a bar plot. Okay, the first parameter will be max dot. So I have some values of temperatures which I want to display. Okay, so I give main the title. Okay, let us say this is maximum temperature, maximum temperature. Okay, in a week, let us say in a week, because I have some, how many, 1, 2, 3, 7 values in a week. Okay, and comma. Then we'll put the X lab equal to degree Celsius or something. Celsius, comma. Then we'll put the Y lab, the label for the Y axis, equal to, let us put days on the Y axis. I'm putting days on the Y axis. Fine. And this is another parameter. This is what we did not see last time. So if I want, I can specify the arguments, the name arguments for the values on the y-axis here. Now I'll give, say, Sunday. You can give it better way. I'm just putting it like this. Okay, if you want, you can just make it much better, the text formatting, you know. Okay, Wednesday, then comes Thursday, Friday, and finally Saturday. Okay, and comma. Let me go down for just 1 minute. Yeah, name arguments I have given all these days to be displayed on the y-axis, and the color. Let us mention the color. Color equal to, let us say, red or dark red. We can also give like this, dark red. Comma. Now in this, I want it to be horizontal. I don't want it to be vertical. I just give HOR equal to true. Okay, this is one thing I just wanted to show you. Excuse me. So here you can see, you know, it is given this values here, and now because it's not able to fit in here, you can see this. We have got the bars. Okay, just because I wanted to show that you can also have a horizontal bars plotted. Okay, we took this example. Okay, fine. So this is one way we can do. There's one option also which called density. Let me show you that also. So density, if I want to set the density of the color which is coming, let us keep it lighter. So if I give, say, 10, you can see this, you get only the lines. Let us increase these values. Let us say 50. Okay, and you can see this. So you can work out with, do some trial error here with density and check how your, the plot looks like. Fine. There's one more option. We saw them stacked bar plot as well, if you remember. In excuse me, just 1 minute. Okay, there's one more way of keeping your instead of a stacked bar. If I want the bars to be sideways beside each other, the bars beside each other, we can do that as well. So for that example now, I think I do have one data here, which is, yeah, this one. This is my, I think this is my matrix. So yeah, that's my matrix. So I have this first, second, third crew, and I have no NES. Now this I have picked up from the Titanic data set. There's a table which is inbuilt table which is available called Titanic. Okay, because I was trying this out. So, I had just created this. So let me show you a bar plot from this matrix to create a, you can say stacked one, a stacked bar plot. So for that, I can just write this again, bar plot. Let me write this function. So I need another one. I cannot. So bar plot. We have 3 minutes in hand. So I'll quickly do this. The name is Titanic data. Okay, there's some data which is available about the survival. You can save depending on each class in this particular, table. And there are some fields like, first class, second class, third class, and the crew members. Then it is again, segregated using gender, male, female. Okay. And the number, how many survived and how many were killed in this particular, you can say Titanic. It's everyone know what Titanic is all about. Okay, so let us give the title, main title. So here I'll give survival of each class. Okay, comma, and I'll give the X label. X label, let us say class wise. So I have classes here. Secondly, I want the color. Now the color I have to give here because I have I have the stacked one, so I have two colors here. So I'll give two basic colors. Let's give red and let's give green also. So red and green. Okay, two colors. And if I run this one now, okay, you can see I'm getting a stacked one. Now, if I want, I don't want this. I can. If I wanted, sidewise. Okay, so there's one parameter. Now the reason for this, I'm not putting any legend or something like here. Okay, the only thing I want to show you is the keyword called beside. Okay, so if I said beside equal to true, okay, so I'll just give a comma. Beside equal to true. Okay, my bar plot looks like this. Okay, so instead of stacking it, it will be just next to each other. Okay, and you can always go and use the legend function to give the legends and indicate what it is. Okay, so I think this is one thing which I had missed last time. Okay, so what I'll do now is we will stop this meeting, and I want you all to rejoin, and we'll look into another type of a chart. Okay, I'll show you the box plot as well, and one more chart we'll see. So please rejoin again.